things we're going to cover are planning versus scheduling, network diagrams, dependencies, critical path, Gantt charts, resources, leveling and smoothing. Okay, so you might have seen recently there's been a lot of advertisements and promotion of the latest book from the APM. So we're going to take this opportunity to plug it yet again. Planning, Monitoring, Scheduling, Control. You can order it now from the APM website. Anyone who's planning on going to Project Controls Expo on the 13th of October can buy it there on the day, and there'll actually be a 20% discount as well there. So most of what I'm saying today is in the book, okay? So it is relevant to today's presentation. And Paul was the lead author of the book, who's available for questions later. And Simon had a massive input, and I had an input into it too. Okay, so planning or scheduling. What's the difference between planning and scheduling? Because there's a bit of confusion here. Often people refer themselves as planners in the title of their job, but what they actually do is scheduling. Okay. What planning is it's almost a deep thought process of deciding what needs to be done, when it needs to be done, what activities we need to do, what resources are required, and how we're actually going to accomplish the project. Okay, so planning is kind of an art rather than a science. All right, it's based on experience. It involves innovation, teams working together, locking themselves in a room for a couple of days, using sticky notes and post-its and things like that to actually, you know, come up with the work and the work breakdown structure. And that's one of the tools they use in planning. Scheduling's more of a science. Scheduling's, you know, about deciding what the start and finish dates are, determining the critical path, leveling resources, and determining what resources you need to do or need to use. So it's more of a science than an art. So they're very, very closely linked, but they are completely separate activities, and often planners have both of these skill sets. So when someone refers to himself as a planner or a project planner, that's what they're actually talking about. And for scheduling, we have all sorts of tools available like Microsoft Project and Primavera. Simon, do you want to add anything to that in terms of planning versus scheduling?
No, I think you just made a point. I think the key thing here is to know that, you know, the planning is a team thing, so it is a collaborative thing, making sure, you know, that many cooks refine this broth. So yeah, really make sure you get everyone involved during the planning process, and then, as you said,
exactly.
scheduling is about, you know, sort of using systems to help, you know, work out the science.
Yeah. Yeah, okay. One of the tools they use, and I was just going to show a quick picture of this. I'm clicking the button, not what's happening. There you go. Is a work breakdown structure, okay? And this is an example I'll be using throughout the presentation, which we're all familiar with, is getting up in the morning, getting dressed and eating breakfast. And you can see there's different levels to the work breakdown structure, and each of those legs break down the activities into more and more detail. All right, so your detail at the bottom is the lowest level, okay, and they're normally what we refer to as work packages. Okay, today's presentation we're focusing on scheduling, so what I want to cover now is network diagrams. Now, there's different types of network diagrams. There's two. One is called activity on node, which is what I'm showing now, and each one of the activities is shown as a node in the network. The alternative to that is what we call activity on arrow. So now the activity is actually on the arrows to the nodes. Now, this one is less and less used. I don't personally like it because in order to complete the logic, you need to have dummy activities to link the nodes together. Okay, so both are used. I prefer the activity on node, and that's the one we're going to be covering today. I also want to talk about dependencies. Now, each activity has a relationship, okay, with its predecessor and its successor. So we have a number of dependencies, of which there's 4. The one on the screen at the moment is what we call the start to finish, the finish to start activity, and this is the most common activity. So what it's saying is activity 2 cannot start until activity 1 has finished. All right. An example of that is going back to a work breakdown structure we used, you cannot make a cup of tea until the kettle has boiled, okay? So the kettle must boil first, and then you can make the cup of tea. Right. Next sort of dependency or relationship is a start-to-start relationship, okay? And what we're saying here now is activity 4 can't start until activity 3 has started, okay? Normally you'd expect them to start at, around about the same time, but the logic's stating here that, activity 4 can start when activity 3 started. And an example of this might be if you was laying a pipeline, for example, that an activity 3 was delivering the sections of pipe, and activity 4 was laying the pipes, then obviously only once the pipes have started to arrive can you actually start work on laying the pipes. However, you don't have to wait till all the pipes have arrived before you can start laying the pipes. So that's the sort of relationship with a start-to-start dependency. The next one is a finish-to-finish, okay, which is kind of the opposite of start-to-start. And what this is saying is activity 6 cannot finish until activity 5 has finished first, okay? And an example of this would be if activity 6 was completing a planning application and activity 5 was the site surveys, then what we're saying is we can't finish the planning application until we've got all the information from the site surveys, okay? So you can actually start the site surveys and you can actually start the planning application, but you can't complete them, okay? So they are dependent on each other. And finally, we have the start to finish activity. Now, this is a bit of an odd activity or an odd relationship because what we're saying is activity 8 cannot finish until activity 7 has started. Now, this is rarely used, and the only example I could come up with here is if activity 7 and 8 were standby and duty pumps, okay? And what we're saying is we can't actually stop the duty pump until the standby pump has been started. Now, it's difficult to imagine that you would actually plan in this level of detail, okay? But it is there, it does exist, but it's not very common. And I think really it should be avoided. Okay. There's then lag and lead. Now, lag and lead is a way of delaying or doing earlier the activities in terms of the relationship. So in the example on the screen here, we've got the start-start relationship. But what we've got a lag of 5 days. So what it's saying is activity 10 can start, but only 5 days after activity 9 has started. Okay. Now it could be considered as bad practice, not always. Okay. Sometimes it's possible that you might want to say wait for some paint to dry before you start to apply the second coat, and this is when you'd use that type of lag to introduce a delay.
I think I just add to the point you made about it sometimes being considered bad practice. There might be maybe a number of reasons for that. Probably the principal one is that in a complicated schedule, it's quite difficult to actually see lag. When the network is put into a schedule, it may appear on a bar chart, etc., and you can clearly see where activities take place. It's a lot harder to see and understand where the lag is. So that's one reason why it might be considered poor practice.
Okay, right, thanks for that. The opposite to a lag is a lead, and basically a lead is a negative lag. So you can see in this example here that activity 12 can actually start 3 days before activity 11 finishes, even though they're on a finish to start relationship. Okay. Again, try to avoid it being used, because if and I have seen this where the lag is so large, the actual logic becomes illogical, because activity 12 can actually start before activity 11, depending on the duration. So again, it is there. All scheduling software allows lags and leads to be used, okay, but try to avoid them where possible. People also see it as a way to compress the schedule, so actually we'll try and start a few of the activities a little bit early.
I suppose just when we start talking about logical relationships, I think it's important that people have in their minds the idea that if you were to take activity 11 and move it and delay it, that relationship would move activity 12 with it. So I think that just remember the purpose of putting these relationships is that one thing, if it moves in time, the other thing is affected by that.
Exactly. Yeah, that's a good point to make. The other point is, as well, is why wouldn't you just have activity 11 a shorter duration? Yeah. So it's things to consider. However, it does allow us to do it in the logic. Okay. Right. Moving on, so we've got these relationships. How do we actually use these relationships? Well, we use these to create a network. And in the network, we have a predecessor and a successor. Okay, every activity should have a predecessor and a successor, with the exception, of course, of the first and the last. This is to ensure that you've got logic throughout your entire network. And as Simon just said then, if one of the activities move, then you know everything else is going to move in a logical sequence. Okay. There are other things which we're not going to cover today, because just purely through time constraints, where you can actually constrain activities to particular times. So we're just going to focus on the logic today. So an example of a network, a very simple network, would be this. So you've got design, which is followed by manufacturing and purchasing, which is done in parallel. Manufacturing is followed by test, as is purchasing, and then they come together at the end to be assembled into a component or whatever. So this is a typical network. However, it doesn't tell us anything about the start, duration, or the finish of each of the activities, or the critical path. So what we need to do is start to add to this network the start and finish times and durations. Okay, so the first question you might ask is, well, which day does the project start on? And you'll find there are two options. It can be day 0 or it can be day 1, all right? Now, there's only one correct answer here, and the correct answer is day 1. However, when you're actually teaching someone how to analyze a network, it's a lot easier of the maths and how to explain it if it starts on day 0, and then there's a quick conversion you can do at the end so that it actually starts on day 1. Okay, so day 0 does not exist in any software tool. However, today I will be showing you examples which do start on day 0, but that's just because the logic is a lot easier to explain. And then once you fill the network in, it's quite a simple task at the end to convert it to a day 1 start. If you try to do it from day 1 at the beginning, the maths becomes a little bit complicated. Yeah, because if something's a 1-day duration, it starts on day 1. Yeah, 1 plus 1 is 2. Well, no, that's not right. It still finishes on day 1 because it started in the morning and it finished in the evening. But I think this will become clear as we start to show you some of the examples. Okay, right. Network analysis. There is actually a British standard for drawing networks, and that's BS 4335. And in there, it's got this little box how we describe it. So it's got EST, EFT, LST, and LFT. Right. What this actually means is the earliest start time, the duration, the earliest finish time. Okay, we use the box in the middle to give an idea or a description to the activity. And we've got the latest start, the latest start time, the total float, and the latest finish time. What I'm going to describe now is where all these numbers come from. Okay, so the earliest start time is basically the earliest time which this activity can start, and it's equal to the predecessor's early finish time. So basically what you do, you take your predecessor, you look at the earliest finish time, and you move that across to the earliest start time. The earliest finish time, well, this is easy to calculate because it's the earliest start time plus the duration, okay? And this is the earliest time by which an activity can finish. So your early finish time is equal to the early start plus the duration. We've also got the latest start time, and the latest start time is equal to the latest finish time minus the duration, okay? And the latest finish time, well, this is equal to the latest start time of the successor. Now, this might seem really complicated, all right, but it will become clear. So I've got a little example of how we do this. So First of all, we do what we call the forward pass. So we start at the beginning and then work out all the early finish and early start times to the end. So in this example here, and like I said, I'm going to start on day 1, okay? So we're going to start, sorry, on day 0. So on day 0, the activity duration is 8, so therefore 0 plus 8 is 8, so the finish time, or the early finish time, is 8. That then moves across to the next activity, and that becomes the early start time. We add the duration, so 8 plus 16 equals 14, and then we can move the 14 across, and then finally we've got the 14 plus 7 equals 21. So in this network, the finish time is on 21. Now we've assumed here that there's no lag within the logic, okay? Right, you might say on a more complicated network, you've got multiple predecessors, so how do we deal with this? So you can see that activity finishes on day 8, and activity B finishes on day 10. So which one do we transfer to activity C? Well, it's the 10, okay? It's the larger of the two, because the logic states that all preceding activities must be completed before succeeding activities start. So what you remember is big steps forward, okay? So there's 2 numbers to pick from. You're doing the forward pass, you take the largest. Quite easy to remember. We then do the backward pass. So now we're starting at the end of the project or the end of the network, and we're working out the late start and late finishes. So the latest start time moves into from the earliest finish time. Okay, it's the same. This time we subtract the duration. So 21 minus 7 is 14. And then the 14 moves across, and the 14 minus the 6 gives us 8, and then the 8 moves across, and then the 8 minus 8 gives us 0. So we're back to the beginning. Again, if there are multiple successors, which number do we use? Okay, so in this example here, it's like, do we move the 8 back, or do we move the 11? Okay, well, we're going to move the 8, and the reason is, going backwards, it's little steps backwards, because the logic states all succeeding activities must be able to start once the preceding activity has been completed. So it's going to be the lowest number that we use on the backward pass. Okay. Right. We also mentioned float. Float is also known as Slack. I think Slack's the American term for it, and Microsoft Project being an American product refers to it as Slack rather than float. Okay, this is the amount of time an activity can move without affecting the total project duration, i.e. the end date. So how much can this activity move or extend or be delayed, okay, without impacting the final end date? And we calculate float by or the total float is simply the late finish minus the early finish. It can also be the late start minus the early start. You get exactly the same answer. So in our example here, you can see 8 minus 8 is 0, so there's no float on any of these activities, all right? So you've got 14 minus 14, that's the late start, sorry, the late finish minus the early finish is 0, and 21 minus 21. And you can see you get exactly the same answer if you had 14 minus 14 or the 8 minus the 8. There's also free float. Now, free float is similar to total float, apart from it's how much the activity can move within its own float without affecting the rest of the networks. It's how much it can move by and have 0 effect on the rest of the network, okay? Total float, you can move it, it will affect the rest of the network in places, but it won't affect the end date. And the reason for this is because those activities are not on the critical path, yeah, because they have float. Anything that's on the critical path doesn't have any float, okay? So the critical path is the path with the minimum amount of float, and this is normally 0, okay? It's very rare you get a critical path that's got actual float in it. It's the longest route through the network. People get confused and think, oh, it's the critical path, it must be the shortest route. No, it isn't. It's the longest route through the network, okay? And you might have more than one critical path, okay? So there can be more than one critical path. And any delay to any activity on the critical path will cause a delay to the entire project, okay, because there's 0 total float. Okay, how do we display the critical path? Well, here's the get dressed example again, or the getting up example, and you can see here I fully analysed this network, and you can see we've got start finish times, and then it's quite easy to spot the critical path because it's the ones which have zero float, which just happen to go across the middle in this example. Okay, right, now I mentioned at the beginning, having used day 0 to do all the calculations and work out your early finish times, your early start times, your float and everything else, we want to convert this network to start on day 1. Okay, and then it'll align with, you know, what software's doing. And in reality, you know, you don't have to actually do this in reality because the software does it for you. Yeah, it's very rare someone will sit down and work out this from first principles with pencil and paper. Everyone these days uses scheduling software tools because, you know, calculating the critical path every time it changed, it would be quite a laborious and time consuming exercise. So what we're going to do now is convert this till it starts on day 1, and it's a simple matter of adding 1 to all the start dates. That includes the start time, the earliest and the latest start times. Okay, so we simply add 1 to all the start times, and now we've got a network which is exactly the same as if you'd run it through you know, Microsoft Project. Okay, what we're going to do now is just briefly talk about Gantt charts. Okay, so Gantt chart is a simple form of bar chart where each bar length indicates the duration of the activity. All right, and we normally draw them so that the earliest one comes first and the last one is drawn last. So there's a nice flow from left to right. Okay. We also show any float at the end of the bars. Okay, and it can be shown with or without the logic. On quite complex programs, if you show it with the logic, because some of the logic might go across the page, on the second page what you end up is these black lines all going through your nice colourful bars, and it looks quite messy. So often on big projects you show it without the logical connection just because it's presented more clearly. Okay, we can also roll the Gantt chart into summary bars. Okay, and we can also use milestones as well. So if I take our getting up example and I just plot it on a piece of paper, this is what it would look like. So you can see get dressed starts on, and I've done it in minutes, minute 1 through to minute 5, and you can see I've included logical links there. And then you got fill kettle, get milk, cook toast, all starting on minute 6, and you can see that goes all the way down to the end where we've got a total duration of 20 minutes. Okay. The float you can see I've drawn in a slightly lighter colour of grey. So we've got float on the non-critical path activities, which are get milk, cook toast, pour milk, etc. So that's typically what a Gantt chart would look like. Now, if we were to draw that in Microsoft Project, this is what it'd look like in Microsoft Project. You can see now also I put the summary bar at the top. Summary bars are quite useful in Microsoft Project as well because you've got a little plus and a minus, and you can actually compress and expand the summary bar. So if you've got quite a long, complicated schedule or program as they're often called, you can actually just look at you can actually roll them up into the summary bars and just expand the bit you want to visualize. All right. In Microsoft Project, a click of the button shows the critical path, and what it does, it draws it in red. And I think you now appreciate all the complex calculations that it's actually doing to work out what the critical path is. Probably complex wasn't the right word there, but laborious calculations. But because computers are good at number crunching, it's an ideal tool to use rather than trying to do it all manually. Again, Primavera does exactly the same, and there are other scheduling tools out there as well. Okay. Mention milestones. Milestones are often shown as a diamond shape, and what these signify is any point on the program that you want to use to say monitor progress. Okay, so it might be an anticipated delivery date, for example, or it might be the end of an activity, or it could be the start of an activity, so you're actually ready to start pouring concrete or something like that. So you can use milestones throughout your program. Beware of using milestones too liberally, because they do affect people's behaviour when you come to deliver the program, because often milestones are seen as a goal that you strive for because they will be used to measure progress, because that's often what they're used for. Have you achieved a milestone yet? So people will focus on delivering milestones. So if they're not on the critical path, you could be focusing people's attention to delivering a milestone at the expense of something which is on the critical path. And we know if it's on the critical path, and that's if it's delayed, it will delay the entire project. So they have to be used with caution, but they are useful. One thing we can use is what we call a milestone chart. And what we've done here, we put the milestones at the weeks or days, it could be, of when those milestones are due. And each week we then plot which milestones have been achieved and when they was achieved. So milestone A, it was due in week 4 of period 1, and it was actually achieved in week 4 of period 1, as was milestone B and C. So they've been achieved of when they was actually required. So in period 7, or week 7 of period 2, we achieved the second milestone, which is milestone B and C. Milestone D was delayed or wasn't achieved on time, and as you can see, it was actually achieved in week 17 of period 4. All right. Now this is quite visual, and what it allows you to do is see which milestones are not being missed or which milestones haven't been hit on time. And it's quite visual because any line that isn't straight, there's been slippage in that milestone. Okay. All right. So it's quite a useful tool. Whether people use that now, because there's obviously reporting facilities in Microsoft Project and Primavera, but normally in the good old days, nice visual representation of where you're up to with all your milestones, and you can see instantaneously which ones are slipping. What I want to do now is look at resourcing, okay? And obviously you assign resource to activities. So taking this example, what I've done now is took my bar chart, which I drew earlier, and I've actually put resources. Now I'm going to assume it's all the same resource just for this example. Okay, often activities have more than one resource type, but just to give you a flavour of how this works. So in the bars or in the boxes, I've actually written how many resources are required. So activity A requires 2 resources in weeks 2, 3, and 4. Activity B requires 4 resources in weeks or days 5, 6, 7, 8, 9, and 10, etc. Okay. What that then enables us to do is to sum how many resources are required on each day. And that will give us what we call a resource histogram. Okay. And what I've done, I've color-coded the activities. So you can see activity here, use 2 resources on day 1, 2 on day 3. When we get to day 5, yeah, activity B is using 4 resources as activity C. So total resources required is 8. Now, just looking at that as a histogram, you can see it's not very well utilized in terms of resources, okay, because we've got peaks and troughs. All right, there's not much resource utilization in days 1 to 4, and day 15, you don't require many resources. However, in days 11, 12, and 13, you've got this peak. One of the things we do as a scheduling activity is try to address these problems, okay? And there's 2 methods we can use to address this, this poor utilization of resource. One's called leveling, and the other one is called smoothing. So smoothing assumes that time is limited, all right? So our end date is constrained, it can't move, all right? So what it does, it allows us to move or extend or split each of the activities within the float. So it's their own float, so it's within the free float, okay? It doesn't affect the project duration, okay? So if it's 20 days, it's still 20 days at the end of the smoothing exercise. The disadvantage is not all of the issues can be resolved, so you still might end up with peaks in your resource. However, it will be a lot smoother than the original resource profile. Okay, what you have to then do is be a little bit creative, and on those days where you need additional resource, you have to get people working overtime, for example, or you have to hire people in for short periods of time, then you release them. In Sellafield, we use agency supply workers for that. So if we've got a short period of time where we require additional resource, we'll bring an agency person in. At the end of that, they'll then be released. So this is an example here of a smoothed histogram. Okay, so what we've done is move some of the activities about. Okay, and you can see now that it's a lot smoother, that the majority of time, you know, it peaks above 8 sometimes, but what I've set in terms of a constraint, as you like, is there was only 6 resources available at any one time. Okay, and you can see what it's done. You can do this manually, and it's quite time consuming because there's lots and lots of different options in terms of moving activities, extending activities. You can even split activities. Scheduling software does that for you at the click of a button, instantaneously gives you the most optimal profile. Okay, so what I've done here, I've actually delayed the start of activity F within its available float, so it's now at the end. All right, and we've now got a smoothed. What we can also do is leveling. Now, leveling, again, assumes you've got limited resources, and it delays or allows the start times to be delayed or extended, and it removes all the overutilization completely. However, it does this at the expense of the end date. All right, so often if you carry out a leveling exercise, what you'll see is your end date will just disappear off to the right. So it has to be used with caution. So this is an example of the same project where we've limited the resources to 6, and we've actually used leveling this time. And you can see that no activity or no day has more than the 6 resources. However, the end date is now day 26 instead of previously, I'll scroll backwards, it was day 18. Okay? So you can see now that it's pushed it out. However, we've solved all the resourcing issues and we've removed any over demand.
A way of maintaining the end date would be to get some more resources. So just want people to know that, yes, obviously that is one balancing of the triangle. We could go and get some more resources, raise our red line up, and that way we can still achieve our end date. We don't have to delay the project.
Yes, exactly. And to be fair, that's what I suggested with the smoothing, yeah? Where you've got the over demand, which I'm sure we know, on days 5 through to 9, what you would do, you would get an additional 2 resources for those, you know, obviously it could be in weeks, so it could be those 4 weeks or 5 weeks or 5 days or whatever. You get additional resources, or you could work overtime with the resources you've got. So there's lots of different options available to us in order to optimize our schedule. All right. All I'm saying here is be very careful if you're using Microsoft Project and you click the leveling button, because your end date is going to disappear off into the distance.
I think the distinction there between smoothing, which doesn't delay the end date, and leveling, which has the possibility of doing so, is a clear distinction to make. If, depending where you are in the supply chain, resource smoothing will be an option to make yourself more efficient, but you may not have the option to use resource leveling where the end date will go out and you won't satisfy the demands of your client. So it's a much more strategic thing when you're talking about resource leveling and pushing dates further out.
The other thing here, this is quite a simplistic example, but it will get more complicated when you've got different types of resource. So if some activities, say, require a design engineer, electrical engineer, and a process engineer, for example, then it gets a lot more complex, and that's where, you know, scheduling software like Primavera and Microsoft Project comes into their own, because, you know, it gives you these histograms and it gives you the opportunity to try and optimize your resources you know, as best as possible. The other thing they will do is split some of the activities if you want them to. Again, these are all options you can use in the software.
The histogram, does it assume that the competencies of the resources to be the same?
Yes, it does. All scheduling software normally assumes, you know, people work 8 hours a day, and for those 8 hours they're completely productive. In reality, everyone knows that doesn't happen. You do things as part of your day job which we wouldn't you know, schedule, like you have to fill your timesheet in at the end of the week, okay, You might be expected to attend safety briefings and things like this. What we tend to do is build all them things into the estimate when we're trying to work out, how much work is required to complete each of the activities. You kind of build that into the activities. So, but yes, in reality, it does assume 100% efficiency on all your resources. In reality, we know that's not the case, but we have to deal with that in other means.
And another way of saying this regarding, I don't know if this is what maybe Vipesh meant, but the competencies of an individual, let's say if I've got 4 different types of designers, each one grade is a different level, you can say, well, I've got 4 separate types of resources. They're all designers, but the competence of the individuals actually do differ. So you could have a histogram purely showing your grade 1 designer, for instance, your grade 2 designers, so then you could come down to a lower level of fidelity around what type of resources that you require.
Yes.
And I think what you're saying there actually starts to answer the second question, which was, in many instances, you would need different resources at different stages of the project. How can this be represented in a histogram? Well, of course, as you imply there, Simon, you can describe different resources, so you can look at both different types of resources, by which I mean different skills, different trades. You could also look at different levels of experience from an apprentice in a certain trade through to a senior expert, and you could make judgments on outputs, etc., as a result if you have on there. But in pure logic terms, that is outside the schedule.
And just for those people that don't maybe know, obviously when we say resources, resources in our term can be a person, it could be some materials, so each one of these could be, for instance, steel, it could be concrete, and it could also be plants, so it could be a piling rig or a digger or something along those lines. So and also money as well, in effect, is also a resource, something that we need to consume. So you have to factor those types of things on. So this is a great way of explaining it simply, but obviously it can become a lot more complex and a lot more informative. What do you choose between Microsoft and Primavera? And right. Just when we talk about the two systems, so Primavera is a very good enterprise tool. So if you're doing an awful lot of planning as a company, you have many projects and many planners, then a good enterprise tool like Primavera is a good solution. Obviously, it's a lot more expensive, but if you want, for instance, if you're doing individual projects and you don't do a lot of project planning and you're getting into it, then Microsoft Projects is a great way to go as well.
It is. If you're using earned value, again, this is more on monitoring rather than scheduling. I think Primavera does earn value a little bit better than Microsoft Project. The reason I say that is, again, Microsoft Project is a little bit Americanized, and I don't think you can have SPIs of more than one and things like that. So there are subtle differences, and you have to start programming around it by using, physical percent complete rather than actual percent complete and stuff like that. So there are differences, but Microsoft Project is great if you're doing a simple project and you want to test your plan and what have you. Often what we do in our organisation is, because obviously Primavera is quite expensive, we'll use Microsoft Project as a project manager. I would use Microsoft Project, but we'll actually put it into Primavera, part of the enterprise model. So you kind of use it as a way to feed Primavera rather than have everybody having Primavera licenses.
Yeah. And another good one came in from Marcel, asking, can planning and scheduling happen at the same time? And this is kind of what I'd have asked Steve and Paul. My perspective on this is it depends on the complexity of the project. If you've got a very simple plan that you as a team are putting together, then you can of course plan and schedule sort of simultaneously, build the scheduling, iterate the scheduling process as you build the plan. That's my own perspective on it, but obviously that that's only in easy if it's a very simple and straightforward project.
I think I'd answer that a bit more philosophically. I think in practice you may well be right, but if we go back to Steve's explanation of planning, and I'm going to characterize it very simply. He called planning deep thought. So planning is the thinking about things, coming up with methods, etc. Whereas scheduling is perhaps more working on a keyboard. And again, I'm being very simplistic about this. but clearly you have to plan before you schedule. And in an ideal world, I would separate the two and say you need to plan things, think about how you're going to deliver before you get into the nuts and bolts of calculating how long that method's going to take. So I don't completely disagree. I think in very simple terms they're going to be iterative processes. But in terms of trying to focus attention for a more complex piece of work, then definitely you need to plan first and sort out your planning and your methods, how you're going to deliver the piece of work before you start calculating how long it's going to take, how long it's going to cost as well, for that matter.
Agreed.
Yeah, I completely agree with that. Yeah, it's a little bit when you're writing computer programs, you know, do you start at the keyboard and start banging away writing code, which is the bit everybody loves and everybody enjoys, or do you stop and think about it in terms of actually how am I going to write this program? And planning and scheduling is exactly the same. You need to sit down, think about what it is you need to do before you start scheduling when you're going to do it, etc. Otherwise, you could miss some of the steps in the dance.
What portion of a project management, say the project management time, should be allocated to planning and scheduling? And this is kind of one of those of age-old questions. And in my opinion, not enough time goes into planning the project in advance. And one of the key statistics around projects failing is the lack of a robust, estimate. And in effect, an estimate is your first plan, and the more thought that you put into it up front, the better chance you have of actually delivering a successful project. And so we know that the MPA has got to show that 68% of projects fail. We're doing almost £500 billion worth of public funded sort of mega projects. So in order to really affect change here, people really need to be looking at spending more time during the planning phase, using scheduling techniques, so we can give ourselves a better chance of doing successful stuff.
Yeah. The thing I'd add to that, Simon, as well, is you don't have to plan everything to the nth degree. So if you've got a 10-year project, you only need to be planning, the next 6-12 months in really precise detail. And, what you're going to be doing in 10 years' time will be quite, I won't use the word vague, but a lot less well-defined. And what we use is ranges. So we have class A, B, C, and D of an estimate. So if it's a class D estimate, you're probably looking at up to plus 100% in terms of the estimate. Where a class A estimate, we're looking at like plus or minus 4%. So definitely the next 6 to 12 months would be a class A. After that, it would be a class B, then a class C, then a class D. So you actually get like a funnel-shaped diagram in terms of the class of estimates. So don't try to plan everything to the nth degree to the end of the project, I would say. You have to do it quite pragmatically.
Should project management time be scheduled? And I went back and basically said that usually the type of the resources, so for instance, project managers who go and it's their job to be there on a daily basis, on a weekly, monthly basis to manage the project, we usually have those as large, they're basic activities that will span the duration of the project, but they are there. They assume that people are going to come into work and just do business as usual stuff on a daily basis, but we use them to capture cost primarily so that we can make sure that we can take into consideration the whole budget for the project.
Yeah. We refer to those activities as a level of effort, so they're not actually detailed. So you wouldn't actually detail that the project manager has to go to his week progress meeting. You wouldn't put that sort of detail into the schedule. You just have one bar covering the duration of each of the phases and have what we call a level of effort on there, so it's captured the cost.
Yeah, however, I would say that in the situation where you have, for instance, so the internal resource that you may use, for instance, engineering for assurance purposes, if those engineers aren't solely dedicated to your team, and it's a good idea to isolate them and separate them out, because what may happen is another project or another project manager might actually have said, okay, I need you to work for me during this week, and if your plan assumes that you have them as a dedicated resource, then it's effectively an incorrect assumption and you're going to have problems. So sometimes, depending on the level of specialty and skill of an individual, even if you feel that they just turn up to work and do things, it can help just to identify, single them out so that you know that they're more importantly, they're aware of what it is they have to do in the plan.
What do you see as the role and importance of a project planner? well, it's hard to overstate it, I think. I think from where we're coming from, absolutely vital. I suppose there's two things. One is project managers need to trust and use their planners to the full of their efficiency. And as planning people, we need to make sure that we are skilled at getting our message across. So it's not just good enough to be good at the software, to be good at even the deep thought, the thinking behind the planning. We have to be able to communicate our plans, our schedules, our ideas, our suggestions well as well. Absolutely vital. There are quite a lot of questions coming in now, Steve.
Okay. Can I just add to that? That something I didn't mention is planning is done throughout the entire project. It's not just something you do at the beginning and forget about. It's, you know, your critical path can change as your progress moves on and things like that. So you need a planner throughout the entire duration of the project, because when things change, you need to plan on how, you know, you're going to react to those changes.
Yeah, and I mean, from my perspective, one of the things I would use for my planners is that they're kind of like, you know, assistant project managers. So they understand the work that's going on, they understand the issues, they understand where the delays are happening, because they're kind of like, they build and they maintain the model, the virtual project, as it were. So, you know, these guys, good planners, are off, they're solving issues, they're talking with the team, engaging with the supply chain, do you know what I mean, and doing their best to help, you know, help support the project manager run the project. And the project managers themselves are then accountable for, you know, really taking on those big issues, hitting those major points, major issues that are going to be delaying the project. But really look to planners, you know, if you are a planner or if you're looking for planners, to sort of be that, you know, a project management support, but obviously with the, you know, the skills for planning and also the skills for scheduling.
The other thing is, Simon, I think we've made a little bit of an assumption as we've gone along here that planners are separate to project managers. In little organisations or small companies, it'll actually be the same person who's managing the project, who's doing the planning and the scheduling. It's only when you get into big organisations, you work on big, complex, multi-billion-pound projects that you have, you know, separate planners and separate cost engineers and separate project managers. So sometimes it is the same person who's doing the job.